Okay, ready? So Alexander Despati likes to blow bubbles when he swims. If he blows a bubble of radius 0.05 millimeters, the last example was 0.5. This is 0.05, much smaller for some reason. When he dives to the bottom of a 10-meter pool, what is the absolute engaged pressure in the bubble? Let's see. Okay, so this is how this one works. Okay, so I'm going to write down here 1 atmosphere. Whoop. Wow, I've never seen that happen before. We have got 1 atmosphere at the top. Okay. Remember how we were calculating out different pressures as you were going through the channel of this? I'm going to draw it over here. Remember there was like this problem where maybe you have, okay, and we were calculating the pressure at different points. So what you were doing was we were measuring difference in heights, Z, X, and you were adding up those differences, and the pressure was going up and down as you take this path. And we're pretty much doing the same thing here, okay? We need to know what the pressure is inside the bubble. So we start off at a reference, and that's going to be, I'm going to work in absolute, okay? So it's pressure at the top is equal to 1 atmosphere, okay? Now, the bubble is 10 meters down, so we have delta P is going to be rho GH, okay? And that's going to be 1,000 times 9.8 times height, 10. You plug that in, you get what? 9, 8, 1, 2, 3. Yeah, okay, that's the number. So the pressure, okay, would be equal to 1.013 times 10 to the 5, right? Plus 9, 8, 1, 2, 3. Okay, so you can plug that in a calculator and figure that out. But wait a minute, I mean, what happened to this whole formula about the bubble and the surface tension? Or does that matter? Yes, it does, okay? Because this is the pressure, okay? Pressure outside the bubble. We want the pressure inside. Pressure inside is going to be equal to the pressure outside plus the delta P, let's call it bubble. Okay? And delta P bubble is either going to be 2 gamma over R or 4 gamma over R. You've got to pick the right one. So you go back to the, whoops, drawing, and we ask ourselves, is this a soap bubble or an air bubble? Oh, it's an air bubble. So it's this top equation. So we're going to use this one. It's not that one. Okay? So we can type it in. Pressure outside. Let me calculate this out. So we continue and we figure out the pressure outside is going to be, pressure outside the bubble we figured out was 1,99300 Pascal, right? That's basic, that's what this is. Okay, plus the pressure of the bubble. The pressure of the bubble is going to be 2 times gamma of water, 7.28 times 10 to the minus 2, divided by 5 times 10 to the minus 5. That's the radius. Okay? So, pull out my calculator, and I got 2912. Add that up, and I get 202,212 Pascal. Pressure in. And that's absolute. Pressure gauge in would be equal to what? Pressure in minus 1 atmosphere, which is 1.013 times 10 to the 5 Pascal. So let me see. Plug that one in. What do we get? 202,212 minus 1.013 exponential 5 equals, I get 100,912 Pascal. Pressure in gauge.